Solving problems in limiting reagent as well as in stoichiometry is one of the most confusing topics in chemistry. Luckily, there is an easy and simple trick which I'm going to teach you in this particular video. And all the problems will be solved using proper experiments so that you could carry some practical value. So without wasting any time, let's start with the first experiment. Now, if you guys are familiar, limiting reagent is the one which is consumed first in the reaction. Now, in this particular setup, I have 10 grams of sodium in which I'm going to add to 100 grams of ethanol. Now, the question is, what is the limiting reagent? What is the excess reagent? And what is the amount of hydrogen gas produced? And what is the amount of sodium ethoxide produced? All these experiments are done by professionals, so please don't try this at home. So let's perform the reaction. Yeah. As you can see, as soon as I added sodium into the ethanol, it started producing hydrogen gas. You can see a lot of bubbles being produced.
A few minutes later.
Now in this beaker, you can see that the sodium is the first thing which got consumed. From this, I can say that the sodium is the limiting reagent. Now, is there another way in which I could say that the sodium was the limiting reagent without actually performing the chemical reaction? Yes, absolutely. There is a mathematical procedure which I'm going to teach you using this particular presentation. I want you guys to know that there is a particular format which you guys need to know before solving all these kind of problems. So the first thing is you have to write the balanced chemical reaction with the proper stoichiometric coefficients. If you don't know what stoichiometric coefficient is, it's this coefficient number which you write just beside the molecule or beside the compound. So you write the balanced chemical equation like this at the top, and you make this kind of table. In the first column, you're going to enter the molecular mass of those respective compounds. So here comes the molecular mass of A. Here comes molecular mass of B. Sorry, I made a mistake here. So here comes molecular mass of B, molecular mass of C, and molecular mass of D. Then in the next column, you're going to enter the mass given according to the question. Suppose say they give 10 grams, you're going to enter, suppose say mass of A taken is 10 grams, you're going to enter 10 grams here. Suppose they give 100 grams in the mass B, you're going to enter mass B as 100 grams here. So the second column is all about writing the mass given according to the question. The mass C and mass D might not be given, but later in the video you're going to understand why these two are also important. Next what you're going to do, you're going to find the number of moles. You're going to convert the mass into number of moles by dividing it with corresponding molecular mass. So you probably know this. Number of moles is mass of the compound given divided by molecular mass of that particular compound. So it's that easy. Just fill this particular compound with number of moles given according to the question. So this is number of moles according to the question. You might not getting the clarity right now, but as soon as you solve the problem, you'll be fully clarified. So make sure you hang out till the end. So in the next column, you're going to divide that number of moles. So what number you're getting in this particular column, you're going to divide with corresponding stoichiometric coefficient. Suppose say you get 5 here, and the stoichiometric coefficient, suppose this A is equal to 2, you're going to write 5 divided by 2 and going to write it as 2.5. That's how you're going to enter the data in this fourth particular column. So you do the same thing for the rest of the rows. So that's the next thing. Next, you're going to see which is the smallest number in this particular column. So that's the most important part. So this fourth column, you're going to see the compound which has the least number. Say suppose you got 2.5 here, and you got 3.2, and here you got, say here probably there won't be anything, but still let us take here you got 5, and here you got something like say 3. Now in this particular column, you have to see the one which has the least amount of this number. Now that number will be your limiting number. In this case, it is 2.5. So my K will be 2.5. Now according to this, my limiting reagent here is A, because my N by S value was 2.5, which is least in this particular column. So that's why the K value is going to be 2.5, 2.5, and this value is going to be same throughout this next whole column. That's the next thing. And next, to find the number of moles in the answer, what you're going to do, you're going to multiply this K value with again with the stoichiometric coefficient. So this is K into A, K into B, K into C, and K into D. Now at last, if you want to find the mass in terms of mass, just multiply this Ka number, Ka, Kb, Kc correspondingly. You know the mole. If you know the mole concept, you probably know the thing. So if you want to find the mass, just multiply number of moles with corresponding molecular masses. You'll get your mass as your final answer. So this was the basic structure of solving these kind of problems. Let me get into this particular example. So in this particular reaction, I took 10 grams of. So in the question, they gave me 10 grams of sodium. So I took 10 grams of sodium and I added to 100 grams of ethanol. Now this is the data you're going to enter. So in the first thing, what I did is I wrote the balanced chemical equation, which is at the top. So 2Na plus 2C2H5OH gives you 2 C2H5ONA plus 1 hydrogen gas. Now I've written its particular molecular masses here. So sodium has 23 as 23 grams per mole, same ethanol and sodium ethoxide as well as hydrogen gas. Now the next data is I'm going to enter the mass given according to the question. Now I don't know the products, I'm just gonna write it as dash and dash here. Now the number of moles, I just have to do 10 divided by 23. So 10 divided by 23 is going to be 0.434. If you have calculator, you can check it out. So the next one, so if I want to find number of moles according to the question, so again I have to take this and divide it by molecular mass. So 100 divided by 46 is going to be 2.17, and this column is just nothing. Next, what I'm going to do, I'm supposed to do n divided by s. Now s is in this case 2, so in the first column it is 2, so 0.434 divided by 2. So 0.434 divided by 2 is going to be 0.217, and in this case I have to just take 2.17 and divide it with, in this case the stoichiometry is 2, so s value is 2 in this case 2, so 2.17 divided by 2. So the limiting number, as I told you, is going to be the one which has least value in the above table. So in this case the least value is in this case. So in this case the least value is this number 0.217. Now this L value is the limiting value is going to be same throughout the whole column. So you just have to compare which is a small number, and just you have to take the smallest number and then enter into the throughout the data. So 2.17, 0.217, 0.217 and 0.217. That's it. So from this you have found that your limiting reagent here is sodium. So in this case your limiting reagent here is sodium. And what is your excess reagent? Limiting reagent is this, and your excess reagent is ethanol. So this is the method in which you can find the limiting reagent as well as the excess reagent. So this is your excess reagent, and this is your limiting reagent. Now you found what is limiting as well as excess reagent. Now the question might be, they might ask what is the amount of hydrogen gas produced, or the amount of sodium ethoxide produced. So for this, what you're going to do, you're just going to take this number and multiply it with s. So 0.217 into s value here is 2. So 0.217 into 2 is going to be 0.434. So this is the in the amount of moles. So 0.434 is the amount of moles of sodium consumed in this particular reaction. So let us see for the ethanol. So 0.217 into stoichiometry in this case is 2. So into 2. So I'm going to get my answer as 0.434. So as you can see, we got the almost same answer, but this doesn't happen every single time, and we can't also guess just by looking into the amount of reactants. We have to do the calculations, then only we're going to get the appropriate answer. So you can't just simply look into the amount of reagents and just judge which is the limiting reagent. Okay, next, 0.217 into the stoichiometry of in this case is so 2. So I'm gonna put it over here, and again I'm gonna get my answer as 0.434. And then in this so 0.217 into 1, so 0.217. So this value what you got in the reactant side is the number of moles of reactant consumed, whereas in the product side you can see this value what is there is the amount of moles of products produced. So if you want to find in terms of mass, you just have to multiply the number of moles with its corresponding molecular masses. So in this it is 0.434 into 23 is its molecular mass. So I'm going to get my answer as approximately 9.9 grams. So in this 19.9 grams, so just have to do 0.434 into its molecular mass is 46 grams per mole, and then in this, so 0.434 number of moles into molecular mass into 68, so 0.434 into 68, 29.512, and at the last, so 0.217 into 2, so 0.217 into 2, 0.434. So this is in grams, of course, in grams. So this is how you solve problems of stoichiometry as well as limiting reagent. This one table is just enough to get all the values whatever you want. Suppose they ask only to find the limiting reagent, you can just end to the fourth column. If they ask every single detail of the reaction, you should probably go through every single step I just said right now. So this is how you solve these kind of particular problems. So let's try to understand this particular concept using one more reaction. You guys probably know that whenever someone adds aluminum to hydrochloric acid, it produces aluminum chloride and hydrogen gas. So the question is, how much aluminum should I add to produce 96 grams of hydrogen gas? Let me show you the reaction first. Okay guys, now let's discuss the second problem. So second problem, I did the experiment. So according to the experiment, aluminum reacts with hydrochloric acid to produce aluminum chloride and hydrogen gas. Now our question was, how many grams of aluminum and hydrochloric acid should be taken to produce 96 grams of hydrogen? So in these type of problems, you need to assume that the reaction is going backwards. So in that case, if you are assuming that hydrogen is reacting with aluminum chloride to produce HCl and aluminum, you'd basically take infinite amount of, like, unlimited amount of aluminum chloride. So you want to produce aluminum and hydrochloric acid from hydrogen and aluminum chloride. So you're kind of going backwards. You're kind of doing the reaction backwards. You're not doing, but you're just assuming you're doing backwards. Now in that case, I'm going to take my aluminum chloride amount as unlimited. So in this case, I'm going to take it as infinity. So if you want to write it numerically, unlimited is nothing but infinity. So number of moles of hydrogen is just 96. So which is mass by molecular mass of hydrogen is 2. 96 by 2 is 48. So number of moles of hydrogen is 48, whereas this is just infinite minus 133.5, which is basically again infinity, and this is just nil and nil. So n by s value for this also is nil and nil, and this is again it's infinity, because infinity by 2 is infinity. So for hydrogen, n by s value will be 48 divided by, so s, if you remember, s is stoichiometric coefficient, which is this in this case. So this is your s value for hydrogen. So this is 3. So 48 divided by 3 is 16. So this was the third step which you want to do. Next, the next step is you just have to see in the n by s column, in this whole column, you just have to see which is the least number. In this least number is 16. So my 16 will be the limiting number in this particular problem. So your limiting number is equal to 16. So I'm going to enter that data throughout this whole column. So 16, 16, 16, and 16. So this was the next step. And the last step is, so your limiting number, so you got your limiting number, just multiply limiting number with stoichiometric coefficients again, you're going to get your product answers. So your answer is going to be 16 into s is 2 here. So 16 into 2 is 32, and here is 16 into 6. So 16 into 6 is 96, and here it is 16 into 2, because stoichiometric coefficient here is 2. So 16 into 2 is again 32, and 16 into 3 is 48. So 16 into 3 is 48. So this is basically the total answer. So if they ask the number of moles of aluminum and hydrochloric acid, so 32 moles of aluminum and 96 moles of hydrochloric acid. Remember, it's in number of moles. So if they ask directly in mass, or they want to know the answer in terms of mass, just multiply number of moles with the corresponding molecular masses. You're going to get your answer in mass. So 32 into 27. So 32 into 27 is going to be 2592 grams. So 32 into 27 is 2592 grams, whereas 96 into 36.5 is 3504 grams, whereas 133.5 into 32 is 4272 grams, whereas this is basically 96 grams, which is given in the question. So you could so this was basically the total answer. So 2592 grams of aluminum and 3504 grams of hydrochloric acid is necessary to produce 96 grams of hydrogen gas. Now the problems could be approached even differently. This table, you could basically find any type of answer. If they just ask number of moles of hydrochloric acid, you can basically let me just change the color. So you can basically just stop till here. If they ask in terms of mass, you have to proceed further and then go till here. And then yeah, this table basically gives every single answer for whatever topic in stoichiometry as well as limiting reagent you want. So yeah, if you just want to know what is your limiting reagent, you can just stop at limiting number. So this column you just need to do and stop it off, and then just judge the answers. Yeah, this table is like an all-rounder for these kind of problems, and this method works every single time for any type of chemical reaction. So there is no exceptional case. It works every single time perfectly. So yeah, this was the end of the video. If you so whatever topic you want to know, whatever topic want to learn, you can just tell me in the comments. I'll try to make a video on that in this experimental and as well as most easiest as well as practical way to understand. So yeah, this was the end of the video. I hope you understood this topic, and I hope you enjoyed this video, and I meet you in the next video. Thank you so much.